Hi, my name is Jessica Perez, and today I'll be explaining Chapter 5, Problem 36 from the book. So the question states, the beam of the negligible weight is supported horizontally by the two springs. If the beam is horizontal and the spring is unstretched when the load is removed, determine the angle of tilt of the beam when the load is applied. So what we have to do is start with our givens, and that's step 1. So we see that Ka equals 1 kilonewton per meter, Kb equals 1.5 kilonewtons per meter, the length of the total length of the bottom is 6 meters, and the force applied is 600 newtons per meter. Step 2 would be to find or determine what we need to find, and that would be the angle of the tilt of the beam when the loads are applied. Then that brings us to step 3, which is to make an assumption, and we can assume that Fa and Fb can be determined by writing the moment equations of equilibrium about points B and A. That then leads us to step 4, which is to make a plan. So step 1 would be to solve for the moment force of A and B by setting it equal to 0. Step 2 would be to solve for the stretch of the springs, and then step 3 would be to solve for the angle by using the inverse sign from the triangle. Step 5 would be to make a free body diagram, and I just restated what the image above said. So the force A is going up, force B is also going up, total length of the bottom is 6, and the force would be 1/2 times 600 times 3. And I also did a diagram of the triangle that's formed and when you solve for the legs, which would be in the solution step. The final step would be step 6, which is the solution process. And so we have to find the moment about A, and we set that equal to 0, so we do Fb times 6, which is the length times the force, which is 1/2 600 times 3 times 2, and you set that equal to 0, and that gives us force B equal to 300 newtons. You do the same thing about moment B, which also equals 0, and you do 1/2 times 600 times 3 times 4 minus F of A times 6 equal to 0, and that gives us 600 newtons. Then you solve for the force of A, which you would do K times X, and that would be 600 equal to 1000 XA. And that gives us XA equal to 0.6 meters. And then you solve for the force of B, which equals KB times XB, which would lead to 300 equal to 1500 times XB, leaving XB to equal 0.2 meters. Then you would input those two length values into the inverse sign. And from there we get the angle length equal to 3.8 degrees. And that is how you solve this problem. Thank you for following along.